Um, Hi, my name is Juan Palomares from BSCS 2A, and today I will present our slides about process management and operating system specific details. New process management. Modern operating system incorporate advanced process management features to efficiently handle the execution of multiple tasks and has enhanced system performance and provide a seamless user experience. Um, Process management is critical aspect of operating system responsible for overseeing the execution of programs and ensuring resource utilization is optimized. Here are examples of new modern process management features. Multitasking, concurrent execution of multiple processes. Process scheduling, algorithms to determine the order of process execution. Process states, management of states like ready, running, blocked, and terminated. Thread management, support for lightweight threads within a process. Um, Process communication, mechanisms for inter-process communication or IPC. Process synchronization, tools like clocks and semaphores to manage shared resources. Next. Deadlock detection and handling, algorithms to identify and resolve deadlocks. Um, Process prioritization, assigning the priority levels to process for resource allocation. Resource management, efficient allocation of CPU time, memory, and I/O devices. Process termination and cleanup, handling the completion or termination of processes. Ano ba? Process monitoring and accounting, tools for tracking resource usage and system performance. Fault tolerance, mechanisms to enhance systems reliability and recover from errors. Um, Therefore, these features collectively contribute to the efficient and reliable execution of processes in modern operating systems, providing a foundation for the diverse and complex computing environments we encounter today. Emphasis on security, process isolation, and advanced features. Security measures. Sorry. Security measures. Access control. Access control. Implement robust access controls to restrict unauthorized access to processes and resources. Encryption. Use encryption techniques for data in transit and at rest to safeguard sensitive informations. Authentication and authorization. Implement strong authentication mechanism and precise authorization policies to ensure only authorized entities interact with processes. Next. Process isolation, containers and virtualization containers and virtualization. Utilize containerization or virtualization technologies to isolate processes, preventing interference and improving security. Resources isolation. Isolate resources such as memory, CPU, and file systems between processes to enhance reliability and security. Namespace isolation. Implement namespace isolation to segregate processes, providing each with its own namespace for resources like network, process IDs, etc. Next. Advanced features. Distributed processing. Support distributed processing to efficiently handle large-scale data processing across multiple nodes. Fault tolerance. Incorporate fault-tolerant mechanisms to ensure process continuity even in the face of failures. Real-time processing. Introduce real-time processing capabilities for time-sensitive applications, ensuring timely executions of critical tasks. Dynamic resource allocation. Implement dynamic resource allocation to optimize resource usage and adapt to varying workloads. Next. Security auditing and monitoring. Logging. Implement comprehensive logging to track and analyze process activities for security auditing. Monitoring. Use monitoring tools to detect and respond to abnormal behavior or security incidents promptly. Next. Secure communication. Secure protocols. Secure protocols. Employ secure communication protocols to protect data exchange between processes. Inter-process communication. Ensure secure communication channels between processes to prevent eavesdropping or tampering. Next. Update and patch management. Regular updates. Keep the process management system up to date with the latest security patches to address vulnerabilities promptly. Patch management. Implement a robust patch management system to efficiently apply updates without disrupting critical operations. Compliance and standards. Annex. Compliance and standards. Adherence to standards. Ensure compliance with industry-specific security standards and regulations. Security and testing. Conduct regular security assessments, including penetration testing, to identify and address potential vulnerabilities. Next. The table shows the comparison with the old operating system and new operating systems in terms of CPU scheduling. Old operating systems or OS has simple algorithms like first come first serve algorithm, while the new OS are using more advanced algorithms like multi-level queue and drill time. In terms of memory management, old OS has limited virtual memory and has simple allocation. In new operating systems, advanced virtual memory and dynamic partitioning. In process management, old operating systems has only basic multitasking and limited IPC. New operating system has robust multitasking, IPC, and process isolation. In security and protections, old operating systems uses only limited user level protection, while new operating systems has emphasis on security and privilege levels. Input-output management or I/O. Old operating systems uses basic input-output and minimal device driver support, while the new operating systems has advanced input-output subsystems, asynchronous and asynchronous operations. User interface. Old operating systems has command line interfaces, while the new operating systems has GUIs, graphical elements, improve user experience. Networking. Older version of operating systems has limited or no built-in networking, while the new operating systems has built-in networking, TCP, IP, advanced capabilities. File system. Old operating system has only basic file systems and it has limited features, while the new operating systems has advanced file system, journaling, and permissions. Reliability and fault tolerance. Old operating system tends to have a limited fault tolerance, while the new operating systems emphasis on reliability, journaling, file system. Resource management. Older version of operating systems has only basic resource allocation, while the new operating systems has dynamic allocation, optimization, and based on demand.